Alright, so if you weren't here the other day, then this is pretty much a review. We're just going to extend on it a little bit. So a lot of the stuff that we did the other day you'll see back in here. And the reason for that is this whole concept of finding a limit at a point to find an average rate of change or whatever you want to call it, it just has so many applications. It's important. Now you may not think this, like exciting, but in terms of making a bridge to word problems and other subjects, I mean this is it. This is one of the things that really connects math to sciences and allows you to do all sorts of stuff with it. So we're going to look at a sort of a plain boring math problem, then we'll put it in context of a sort of a gravity problem, something that we've dealt with in the past, and hopefully we can expand on it a little bit. So what do we have here? We got a right circular cone. The height is 6 and the radius is r. So that means that the height is fixed, but the radius can get smaller and larger. So your volume isn't fixed either. You have a formula that's given to you that describes what the volume is. So the volume depends on the radius. It's 2 pi times r squared. And we want to find the instantaneous rate of change of the volume phi with respect to the radius r with r equal to 3. Oh, that's just a whole lot of words that's trying to ask you this. We need to find f prime at 3. Okay, we have this thing for that. We need x to go towards 3, so we're going to approach 3, and we're going to take the function, we're going to subtract the function's value at 3, and we're going to divide that whole thing by x minus the 3 that we're interested in. So at this point, one of the things that you can do is you can substitute in for your function. So the function is what? F of x is, in this case, it's not with an f, but the function is 2 pi r squared minus the function's value at 3. So we need to find the volume at 3, which would be 2 pi times 3 squared, which is 18 pi. So we're going to subtract 18 pi from that. We're going to divide all of that by x minus 3. But x is actually what? R. So should probably erase this x and write it with r's. Because we're actually interested in the variable r. Okay, so you have to identify your x's and your f of x's a little bit in context. Okay, what do you know about the top and the bottom? What do we know about the top?
The top is 1 degree bigger than the
Okay, what else do we know? Because we're finding a limit here, what do we know is going to happen? Yeah, this is definitely factorable. Factorable, and actually you know that one of the factors in the top is going to end up being what? R minus 3. Okay, you can't, well, you may be able to see it, but take out the 2 pi first, and you would end up with r squared minus 9. Okay, now hopefully you can see that you are going to be able to factor out r minus 3. So we're looking for the limit of r approaching 3. And the top says 2 pi, r minus 3, r plus 3, and the bottom of our expression is r minus 3. Those cancel, so actually we just need to find this limit. So used to writing an x there, sorry. So r going to 3, 2 pi, and then r plus 3. So one step left. Plug in 3. Right there. 3 plus 3 is, times 2 is, so what does that mean? 12 pi what? What does that mean? The 12 pi represents? Okay, in context of the problem, what does that represent then? So we're saying something like the slope here is 12 pi. What rate of change? What's changing? the volume. So the volume, and you should be able to write something like this. When R equals 3, the volume is changing by 12 pi what? What unit will volume have here? Feet, and it's volume, so it's cubic feet. For every 1 foot increase in radius. Because keep in mind this 12 pi represents a slope, and slope is usually a fraction, with the top one being your change in y. That's the 12 pi cubic feet, and the 1 represents what? In this case it's a 1 foot radius. So at R equals 3, the volume is increasing by 12 cubic feet for every 1 foot increase in radius. You should be able to put that in context, because it's not just 12 pi, it actually describes something a little bit more than just 12 pi being a slope. Okay. I can also ask things about instantaneous speed, which is just another way of looking at a derivative. Because keep in mind, speed is a change in position versus a change in time. Right? Distance over time. Well, that would fit the pattern here then. So I don't think the next problem is a speed problem. Well, actually it will be at some point. It's going to change into a speed problem. So the next problem we'll do, you'll sort of see where speed comes into play. In general, if we're looking at this sort of just mathematically, then the derivative, yeah, it represents a slope. You know, it's the slope, the tangent line to the graph, blah blah blah. So yes, but in physics, for example, it could be velocity. Okay, if you have any two variables, so this would then apply to a broad range of sciences. Anytime there's a relationship between two variables and you were given that relationship, so you're given a function, then the way that that function changes can be described with a limit, and you can find that limit. You just take the function, subtract the point that you're interested in, divide it by the variable that you're interested in, and you subtract the point that you're interested in, which is that f of t minus fc over t minus c. It's the same thing over and over, just it has so many wide applications that this is, you know, sort of big stuff. How would that look in a problem like this? We've done this problem many times in parts. Now we haven't really done d through h, but you know, that's the new stuff. But a, b, and c we should have no problem answering. So height of the ball, initial speed is 80 feet per second, and the rooftop is 96 feet high. Hopefully you can see the initial velocity here and the height of the rooftop right there. Okay, that's those two numbers. Where does the negative 16 come from? What do you think the negative 16 has why is that important? Where does that come from in this story? So gravity. It's the thing that makes stuff go down, and we have a name for that, and that's called gravity. The gravity is related to the negative 16. See, all these numbers have a reason for being there. Okay, when does the ball strike the ground? How do you find that? And this is about the point I quit teaching earlier today because I got ticked off. Yeah, the height is 0, right? When the ball is on the ground, how high above the ground are you? 0. So I know you guys have a whole, and I have a whole slide too, so I'm just going to set this up initially. So we just need to find this. Okay, last time I checked, most of you did that in Algebra 2 with me. Okay, that's like a year and a half ago. Now we have seen it again this year as well. So can we solve a quadratic? Okay, so we'll do that here in a second. If I'm looking at B, it says, at what time will the ball pass the rooftop on its way down? So what do you need to do there? Plug in 96 for Y. Right. Your distance above the ground for B will be at 96, and then apparently we're supposed to solve this one. Okay, that one's actually a little bit easier to solve because the factoring is easy. Are we okay with what we're going to do for A and B? So I'm going to go through that sort of quick, because I cheated and I have notes. Alright, so for the first one, a negative 16t squared plus 80t plus 96. I can take out the negative 16 actually, and then you factor this, and we get two answers. So how do you know which one's right? The positive time, right? So it's going to take 6 seconds for that ball to hit the ground after you toss it. Okay? So in B, we said that the 96, that's the rooftop, so that would be, I toss it up and I'm interested in how long would it take to get back down to the level that we were on. So and I said this one is easier because you can cancel those right away. So then this factoring becomes a little bit more straightforward. You end up with just t minus 5. So that would be two t's as well. T is 0 and t is 5. So which one am I interested in? Clearly? Yeah, because the t is 0, that's when I'm holding the ball in my hand. So I didn't care about that. Okay. C, that's Kyle's solution to the problem that we did on homework. We're asked for average speed in C. And the two times that we're interested in, I think, are 0 and 2. Is that right? Okay. So how do you find average speed? Well, you find the change in y divided by the change in x. So what is the distance at 0? It's 96. What is the distance at 2? How would you find that? Just plug in 2, right? So that's 192. I plugged it in for you. It's 192. So you do 192 minus 96 divided by the change in x. We're going from 0 to 2. So that ends up being 48 feet per second. Okay. Is everybody okay with that? I know it's a little fast, but this is sort of the review, and at this point I'm definitely going to slow down. Alright, so here's your new question. This is the new stuff. So D says, what is the instantaneous speed of the ball at time t? Sorry, can't compete with that. Alright, so we're being asked to find the limit of t going to t, and that's a little confusing, isn't it? So we're going to make that one a t sub 0. And we need to find that limit by taking the function, subtracting what we get when we plug in t sub 0, and dividing that by t minus t sub 0. Well, the first part there is not too bad, because that's just copying the function. And the function is a negative 16 t squared plus 80t plus 96. The second part there is, at this point, not too bad, because I'm just going to replace every t with a t sub 0. So I have a end up with this thing. And then we're going to divide all this by t minus t sub 0. Okay, I'm going to distribute this negative. So that becomes 16 squared, or 16t squared for the 0, minus 80t sub 0, minus 96. then doing one more stuff that's sort of straightforward. It's just cleaning it up a little bit. And I'm going to write everything that has a square first, and then we'll write everything that has a t. And then what happens with 96 minus 96? Good. So I cleaned it up, I reordered it, and I changed it a little bit in terms of the order. But none of this really is yet where it becomes maybe a little bit strange. So I'll let you catch up for just a second. Okay, so the next idea is that what do you know about all these limits in terms of the top? The top is factorable, right? And one of the factors has to be what? T minus t sub 0 in this case. So somehow I need to get that t minus t sub 0 out of here. And that sometimes is a challenge, but any suggestions? Where can I start? Where can I start factoring? What's the first, well, what is the first thing you should always look for in factoring? Yeah, take out your common factors. And in this case, start with numbers. So I'm actually going to take out a negative 16. Is that okay? So that makes all these signs switch. Then what? I'm just copying the parts that we know we're going to end up with anyway. Anybody see any factoring yet? Give you a hint. That's an x squared minus y squared. How does x squared minus y squared factor? That's t. Nope. Isn't x squared minus y squared just x minus y times x plus y? Yeah? Well, don't worry about the negative 5 and all that stuff there yet. We'll deal with that in a second. I was just interested in this part here. That's a t squared minus t squared. That's an x squared minus y squared. Or an a minus b, a squared minus b squared. It's a conjugate pair. So there's your t minus t sub 0 that we're looking for anyway. And then we have a negative 5 here, and we have a 5 there. So can I take out a negative 5? What does that leave you? T minus t sub 0. Okay, take another look at that. You can take the negative 5 out of a negative 5t. So this negative 5 divided by negative 5, that positive divided by negative 5. So there's your negative 5 that makes it t minus t sub 0. There's a factor that we're looking for. And then here you get t minus t sub 0 times t plus t sub 0, because that's t squared minus t squared. Okay, now do I have a common factor that I can cancel out everywhere? Right. I'm going to change my color again. Well, just the brackets here. That's the factor t minus t sub 0. Well, I can divide this thing by it, and then this thing. So it cancels this way. So that allows you to rewrite this one more time before we need to fill it in. So we're going to get t sub 0. You get a negative 16. Then inside the brackets you get t plus t sub 0, that's a plus, minus 5. Now what do? If this said t going to 4, what would you replace the t with? So here you replace your t with t sub 0. So the limit of that thing goes to here. Yeah, I don't really care what you call any one of these. So if you want to go from t to x or y or m or n or p, it doesn't matter. It should all work out, right? Because I picked a t sub 0, right? So I picked it because that's what's in the book. So if you ever look at the book, it should match. Okay. So if you're wondering why would I go through all this, well, this thing allows me, this will find the slope, or in this case instantaneous rate of change, which is actually, it will find the speed of the ball at any point, well, at any point between 0 and 6, because the function only goes from 0 to 6. So when it says E, what is the instantaneous speed when you're at t equals 2? What do you just do? Plug in 2. And when you do that, what do you get? Sorry. You got 16. And that's feet per second. Okay, when is the instantaneous speed of the ball equal to 0? So that's asking you this. When do I get 0 out of this? Why is that point important? Why would we want to know when the speed is 0? Yeah, it's the vertex of this parabola thing, right? I messed up there. That's the time at which the ball has reached its highest point. That would be when? When t is 80 divided by 32, which ends up being exactly 2.5. So if you want to know when does it reach its highest point, it's 2.5. Then what could you do to find the highest point? Plug in into the original. Very good. So don't plug it back into the negative 32t thing. Plug it into the original and you would find it. Okay, how about G? It says, what is the instantaneous speed as it passes the rooftop? Well, when did it pass the rooftop? When t was 5. So we already figured out that t, so we do negative 32 times 5 plus 80, which should give me a negative velocity, right? Which actually is a negative 80 feet per second. That should make sense because the ball is going down. If initially up is a positive, then down should be a negative. And then h, when does it hit the ground? When t is? At what t does it hit the ground? At 6. So you plug in the 6. And if you plug that one in, you should end up with a negative 112 feet per second, which would be the maximum velocity this ball ever reaches. Okay?